This is section 2.5, proving statements about segments and angles. So we're going to learn how to write proofs today. And a proof is basically just a structured argument as to why your answer is correct. So we did this with algebraic reasoning. We didn't necessarily put it in the form of a proof. So we're going to learn how to put it in the form of a proof. But basically what it is that you're saying, this is my statement and this is why it's true. And then you logically go through all of the steps until you get to your answer. So we're going to focus on two-column proofs today. So a two-column proof has numbered statements and corresponding reasons that show an argument in a logical order. When we're doing proofs, we use deductive reasoning. We don't use patterns, we use rules. So a lot of times you're going to use definitions or postulates or theorems as your reason. And you're going to do it step by step until you reach your conclusion. Your first statement is always going to be the given, and your last statement is always going to be the conclusion. So let's look at a couple of examples of two-column proofs. So this is an example of a proof that's already filled out for you. So we are given that measure of angle 1 is equal to the measure of angle 3, and we are trying to prove that the measure of angle DBA is equal to the measure of angle EBC. Okay, this is one we went through in a previous lesson, and now we're going to do a formal proof for it. So your first statement is always going to be your given. So we're always going to have what's here, and our reason is always going to be given. Okay, so you should never, ever, ever miss the first line of a proof. And then we're going to try to figure out how do we get from what we're given to what we're trying to prove. So in this case, we're going to say that the measure of angle DBA is equal to the measure of angle 3 plus the measure of angle 2 to get us that whole big angle right here. And that's by the angle addition postulate. Okay, so that means the bigger angle is equal to the smaller angle plus the smaller angle. So part plus part equals whole. And we're going to, we know here given to us by these little bars right here, or these little marks, that angle 1 and angle 3 are congruent. They're the same thing. So instead of angle 3, we're going to write angle 1 by the substitution property of equality. Remember, substitution says that if two things are the same, you can substitute or switch them out, and it doesn't change anything. Okay? And then we also know that the measure of angle EBC, okay, this big one here, is equal to the sum of the two smaller angles by the angle addition postulate again. And then notice what we have here. I see a measure of angle 1 plus the measure of angle 2. The measure of angle 1 plus the measure of angle 2. And we can use the transitive property, remember, that says that if A equals B and B equals C, then A equals C. We can use that property to say that DBA and EBC, that they have the same measure. All right, so let's do an example where we have to fill in some things. Okay, so we are given that T is the midpoint of segment SU, and we're trying to prove that X is equal to 5. So the first step of a proof is always, always, always the given. So T is the midpoint of SU, and we know that because it is given to us. All right. We also know from that segment ST is congruent to segment TU because we are given that it's a midpoint. Remember, the definition of a midpoint is that it cuts it into two equal parts, into two congruent parts. Then we can go from saying that those two segments are congruent to saying their lengths are equal by the definition of congruent statements. Okay, or segments. What it means to be congruent is that they are the same size or they have the same measure. So now we have a blank to fill in. We got to think, how did we get from ST is equal to TU to 7x equals 3x plus 20? Well, those expressions come from up here. We know that ST is equal to 7x, and we know that TU is equal to 3x plus 20. So this is the substitution property of equality. Okay, we're just substituting in what that actual value is for ST and for TU. And our next one, we know that we're going to use the subtraction property of equality. And if we go back thinking of how we would solve this, I'm going to subtract 3x from both sides. So my next statement is that 4x is going to be equal to 20 because we subtracted 3x from both sides. And then same thing, how do we get from 4x equals 20 to x equals 5? Well, solving this would tell us to divide by 4. So we're going to use the division property of equality to get x equals 5. We've finished it because we've gotten to our proof statement, so we are done. So what you're doing is you're forming a logical argument, trying to use postulates and properties and theorems that we have learned previously to fill in this proof. Please note that this is your first time doing a full-on proof, so it is not expected that you're perfect with it. That's okay, we're going to do a lot of practice. If you have questions, make sure that you're asking them, but just do your best.